Welcome to iMatter Learning Center, where every learner matters. I'll be walking through the topic on congruent and similarity, a lower set revision guide. In this revision guide, I'll be sharing with you on the idea of congruent versus similarity. You must be able to distinguish congruent versus similarity. Next, we will be learning how to write the standard notation of expressing congruency and similarity of a pair of figures. In this presentation, I'll be using a pair of triangles to prove congruency versus similarity. Next, you must be able to visualize the transformation of congruent figures. Lastly, I will be sharing with you strategies and common mistakes. Distinguish the congruency versus similarity is the very first step. For congruent figure, they have a unique property of having the same shape and sizes. This simply means that figure A must be able to overlap figure B. I would like to explain a, a bit about the letters and the angles. The upper caps letters represent the vertices of the figure, while the lower cap letter represent the different type of sides. The color angles represent different type of angles. Next, we shall present to you the similarity. Similar figures have same shape but different sizes. Looking back at all three figures, it is unwise to use three angles to prove congruency. Before we learn how to write the standard notation of congruent figure, let us take a look at the condition that define congruency. If two triangles or figures are congruent, all congruent sides are equal. All corresponding angles are equal as well. You must be able to recognize that the sides and angles of figures define the shapes and size of the figures. When these two figures, figure A and figure B, are placed side by side, these two conditions must be able to fulfill. As what I mentioned earlier, if both figures are congruent, these two figures will overlap each other completely. Once we confirm that these two figures are congruent, we will proceed to write the standard notation of congruent figure. So in this case, the standard notation is as follows, where vertices E will follow vertices Y, vertices F will follow vertices X, and vertices G will follow vertices Z. Note that a triple line is used instead of the normal equal sign used in mathematical operation. This sign is used to denote congruency. Let us take a look at an example of congruency of figures. When we look at this problem sum, we will notice that not all information are presented. The figure on the left shows that the indicated side is in between two angles, while the figure on the right, the indicated side is not between two angles. So you must ask yourself, is there sufficient information to prove congruency of figure? So yes, you use the sum of angle in triangle equal to 180 degree to obtain this angle which indicated in red. and you realize that these two figures are actually congruent. Therefore, point 1 and point 2 matches. These are some essential information when it comes to proving similarity or congruence. Do note that these four pairs of reasoning only occur when there is a pair of parallel sides denoted by a pair of arrows. So when we say that this pair of vertically opposite angle, this an example will be angle A is equal to angle C. An example of corresponding angle will be angle A will be equal to angle E. Another example when it comes to alternate angles will be angle C will be equal to angle E. And lastly, a pair of interior angle will be angle D equal to angle C. For this piece of information, the sum of angles angle K and angle M, which is inside the triangle, is equal to the angle I, which is outside of the triangle and bound by a straight line. For angles on the straight line, the sum of angle I and angle J is equal to 180 degrees. Likewise, angles in the triangle, mainly angle J, angle K, and angle M, must be equal to 180 degrees. The moral of this slide is to tell you that knowing the properties of different figure and computation of angle assists in identification of congruent or similar triangle. Being able to visualize the transformation of congruent figure is very important. This is especially so when in the case of a pair of congruent figure, one congruent figure is in one orientation and another figure is in another orientation. The first combination I would like to show is rotation. The second combination I would like to show is reflection, where there's a plane or symmetry. The third combination is translation. Basically, the image replicate to form another congruent figure. When it comes to presenting the standard notation of similar figure, one must realize that the condition defined for similarity differ from the condition defined for congruent earlier on. When we say that two triangles or figures are similar, it simply means that all corresponding angles must be equal, and there is a skew factor of A is to O, B is to P, and C is to Q. The skew factor simply means the ratio of the corresponding side. It simply tells you how large or how small with respect to the reference figure. In this case, the reference figure is figure C. If we want the reference figure to be figure A, the, the numerator and the denominator have to swap position. Now, after we prove that these two figures are similar, we will then proceed to write the standard notation. Note that instead of the triple equal sign, we will write is similar to denote that triangle EFG is similar to triangle MSO. Recap back that similar triangles have the same shape and but different size. I would like to present to you a problem sum relating to the similarity of figure. I would like to prove whether triangle ABC is similar to triangle AED. Do note that there is sufficient information for angles to satisfy condition 1, but there is insufficient information for condition 2. I forgot to mention that AOBPCQ are the length of respective sides. So coming back to the proving of similarity, okay, in order to prove these two triangles are similar, we must realize that we must get all three angle information. So the angle in black is a common angle in triangle ABC and triangle AED, whereas triangle whereas angle ABC and angle AED is a pair of corresponding angle. Another pair of corresponding angle will be angle ACB and angle ADE. Therefore, once we are able to get all this information, we can proceed to write the standard notation where triangle ABC is similar to triangle AED. In the case when skew factor is known, example 3, if we would like to find the length of AC, we will need to use an algebraic letter to find out the unknown side. Many students do not understand how to use an algebra, so this is a tip when to use algebra in this situation. So make sure to do your operation correctly and you get x equal to 7.5 centimeter. In a nutshell, I would like to showcase the entire process. When you are missing information, okay, do make sure to fill it up so that you can prove the congruency or similarity of a pair of figures. When you have sufficient information, you can then proceed to write the standard notation. For similarity, you write triangle EFG is similar to triangle YXZ. For congruency, you write triangle EFG is congruent to triangle YXZ, where congruency is represented by the three lines. Lastly, if the question asks you for a particular side of angle, do make sure to use a notation to compare side by side, or if there is insufficient information when they give you a standard notation like the previous slide, then you use algebraic to actually find out the unknown side. We have come to the end of lower set revision guide on the topic of congruent versus similarity. I hope you have a great understanding of what I have taught. Thank you so much and goodbye.